It's July 16, 1969. The world holds its breath. Somewhere in Florida, at a place called Cape Kennedy, a silver-white rocket, taller than the Statue of Liberty, groans under its own weight, bathed in a flood of spotlights and anticipation. Three men sit inside a tiny cabin strapped atop a 363-foot-tall behemoth. They don't know if they'll ever come back. They don't know if they'll even survive the next 5 minutes. All they know is that they're about to make history. This isn't just a rocket launch. This is Apollo 11. Before we take you aboard this epic voyage, we want you to ask yourself, what makes humans look at the moon and say, let's go there? Why was this mission so vital to the United States that it risked billions of dollars in human lives? And how did three men in a glorified tin can actually survive a journey across 240,000 miles of raw space? Don't blink, because this is not your regular history lesson. We don't just tell you what happened, we take you there. Oh, and while you're here, if you're fascinated by the dark mysteries of the universe, like the birth of everything in the Big Bang or how our chaotic solar system really formed, we've covered that in haunting detail. Check the links in the description and subscribe. Trust me, you'll never see the universe the same way again. Now, back to Apollo 11. What made it more than just a mission was its sheer scale. This wasn't just another space launch. It was the final chess move in a decades-long geopolitical race known as the space race. After the Soviet Union shocked the world by launching Sputnik in 1957 and then sending the first man, Yuri Gagarin, into space, the U.S. was desperate to catch up and overtake. John F. Kennedy, with his famous 1961 speech, made a promise that seemed almost impossible: to land a man on the moon before the decade ended. Apollo 11 was America cashing that check. Now let's talk about the spacecraft itself. Because this wasn't one ship, it was three. Three perfectly engineered components that each had to perform flawlessly in the most hostile environment known to manned space. First, there was the Saturn V rocket, an engineering monster. Standing at 363 feet tall, this thing wasn't a spaceship. It was a skyscraper filled with fuel and fury. It had 3 stages. Stage 1, powered by 5 F1 engines, generated 7.5 million pounds of thrust. That's the force needed to lift a weight equivalent to 400 elephants straight into the sky. Its job? Get the spacecraft out of Earth's thickest atmosphere layer. Stage 2 took over next with 5 J2 engines. Smaller but still ferocious, it pushed Apollo 11 into space. Stage 3, the final push, used a single J2 engine to propel the crew into orbit, and later ignited once again for the translunar injection, a fancy way of saying, let's head to the moon. Sitting at the top, nested like a Russian doll, was the command and service module called Columbia. This is where Neil Armstrong, Buzz Aldrin, and Michael Collins would spend most of their journey. Columbia was the brain and life support of the mission. It had oxygen, water, computers, navigation systems, and the heat shield that would eventually protect them during the fiery re-entry into Earth's atmosphere. But it wasn't built to land on the moon. That was the job of a separate, spider-like machine known as the lunar module, codenamed Eagle. Eagle was weird-looking. It had no smooth edges, no symmetry. It looked like something cobbled together in a scrapyard. But it was light, extremely light. It had 2 stages: the descent stage, with its gold foil-covered legs and thrusters to land on the moon, and the ascent stage, which would later blast Armstrong and Aldrin back into lunar orbit. Eagle had no seats, no backup systems. It was barely more than a flying metal tent. But if it failed, those 2 astronauts would die alone on the moon. Nixon even had a speech written in case that happened. Liftoff, July 16, 9:32 a.m. Eastern Time. The engines ignite. The Saturn V roars like the wrath of a god. Millions of people watch as the rocket climbs through the clouds. For the first few minutes, the astronauts are pinned to their seats with force 3 times their body weight. Stage 1 burns for 2.5 minutes before separating. Stage 2 kicks in, pushing the spacecraft higher and faster. Stage 3 brings them into Earth orbit, but we're just getting started. After checking all systems, Stage 3 reignites. Apollo 11 performs the translunar injection, leaving Earth's orbit and beginning its 3-day journey to the moon. But they're not just flying straight. They perform a maneuver called transposition and docking. This part is like cosmic ballet. The Columbia module detaches, flips around in space, and docks with the lunar module still tucked in the third stage. Then, the combined spacecraft Columbia and Eagle pull away from the spent rocket stage and head for the moon. 3 days later, they enter lunar orbit. For the first time in human history, 3 men are orbiting the moon, peering down at its silent, cratered face. Then, the moment arrives. Armstrong and Aldrin climb into Eagle. Collins remains in Columbia, alone. If anything goes wrong down there, Collins can't help. He can't even talk to them during parts of their orbit. It's the loneliest job in the universe. July 20, 1969. Eagle undocks, begins its descent, but things start going wrong. The computer throws alarms. 1202. No one knows what it means. Turns out, the computer has overloaded too much data at once. Back in Houston, engineers scramble. Finally, a young controller named Steve Bales says it's okay. The mission continues. Eagle is descending too fast. Armstrong sees the landing site is full of boulders. He takes manual control, burning fuel. The descent engine hisses. Dust kicks up. The world goes silent. And then, those words. Houston, Tranquility Base here. The Eagle has landed. It's 2017 UTC. Neil Armstrong and Buzz Aldrin have landed on the moon. 6 hours later, the hatch opens. A foot descends the ladder, and Armstrong steps onto alien soil. That's one small step for man, one giant leap for mankind. But here's something people often miss he was supposed to say, one small step for a man. He flubbed it, but no one cared. The moment was too enormous. Buzz Aldrin joins him. They plant the American flag not to claim the moon, but to signal that humanity had arrived. They place a plaque, "We came in peace for all mankind." They set up experiments, a seismic detector, a laser reflector. They collect rocks, and they bounce around like kids on a trampoline, but every moment was under pressure. Their suits were their only protection from the vacuum. A rip, a malfunction, a single wrong move, and they would die in seconds. Even the flag almost didn't stand. They had to jam it into the soil with force. The moon's dust, by the way, is sharp, like ground glass. It clings to everything. It smells like gunpowder. After 2.5 hours, they climb back into the Eagle, but they still have to launch back. And the ascent stage, it uses a single engine that had never been tested in vacuum. If it failed, they were doomed, but it worked. The ascent stage ignited and blasted them back into lunar orbit, where they reunited with Michael Collins in Columbia. From there, it was another 3 days back to Earth. They jettisoned Eagle's ascent stage, fired the engine to escape lunar orbit, and coasted home. But the most dangerous part still lay ahead: re-entry. Earth's atmosphere is unforgiving. Enter too shallow, and you skip off like a stone on water. Too steep, and you burn up. Apollo 11's trajectory had to be exact. As they plunged into the atmosphere at over 24,000 miles per hour, the heat shield endured temperatures of 5,000 degrees Fahrenheit. Plasma surrounded them, cutting off all communication for minutes, and then splashed down. July 24, 1969. The Pacific Ocean. They were back. Alive. Heroes. But why was this so important to the USA? Because it wasn't just about science. It was about proving a point. That in the race of ideologies, democracy vs. communism, America had the courage, brains, and willpower to do the impossible. It was a global statement, but beyond politics, it changed how we see ourselves. For the first time, humans had left Earth. We had walked on another world. It changed everything. The risks? Almost infinite. The rocket could have exploded on the pad. The spacecraft could have malfunctioned. The landing could have failed. The moon could have been more dangerous than expected. And re-entry? If the angle was off by even a few degrees, they'd be gone. Even after returning, they had to be quarantined for 3 weeks because scientists weren't sure if the moon carried alien microbes. It sounds wild now, but they had no idea. And the technology? Think about this. The Apollo guidance computer had less processing power than a basic calculator. The entire mission was run on slide rules, handwritten checklists, and raw nerve. Every move was manual. Every problem had to be solved on the fly. And yet, it worked. The legacy of Apollo 11 isn't just footprints in dust. It's a blueprint for human achievement. It proved that when we dream big, work hard, and face the unknown together. But here's the real mystery. We haven't gone back since 1972. Why? Was it money? Politics? Or something else? We'll explore that in a future video. This is what we do. We dig into the biggest, darkest, most mind-blowing scientific mysteries, from the birth of time itself, in the Big Bang to the chaotic birth of the solar system. If you haven't seen our Big Bang breakdown yet, you're missing out. It's not just science, it's cosmic poetry. Link in the description. And if you've ever wondered why the planets formed the way they did, or why Earth even exists at all, we've unraveled it in our solar system episode, also linked below. So what's next? Maybe Mars, maybe beyond. But for now, look up at the moon tonight. Somewhere up there, still sitting in the dust, is a flag, a plaque, and the footprint of a man who dared to take the first step.